In this video, we'll be talking about theoretical versus experimental probability. Those two are different things. In theory, what can happen versus in experiment, by doing it, what can happen. So theoretical probability is the expected chance that your event will happen, calculated by comparing the number of times the event occurs to all the possible outcomes. Experimental probability is slightly different. It is the actual number of times the event occurs by trial, calculated by comparing the number of times the event occurs to the number of times it was performed. So the experimental probability is what happens, how many times the event happens, out of the number of times you tried, okay? Out of the number of times that was the event performed. For example, in a die, when we roll dice, we have 6 possible outcomes, right? So we can get a 1, a 2, a 3, 4, 5, or 6. In theory, the probability of rolling a 6, so the probability in theory, or theoretical, TP, theoretical probability of rolling a 6 is 1 out of the 6 possible outcomes. So 1/6 is approximately 17%. Low chance of getting a 6. Now, the experimental probability is how many times we see a 6 out of how many times we actually do the experiment. So let's say I roll the die, I roll, and I get the number 6 2 times. Out of, maybe I rolled my dice 15 times. So I rolled my dice 15 times, and only 2 times I got a 6. Maybe you roll the die 15 times and you can get the 6 4 times or 5 times. Maybe you do 15 rolls and get a 3 times 6. So the experimental probability is something that changes based on your luck, let's say, or the way you roll, or the day, or so experimental probability is varying based on different things. Theoretical probability is always the same. There is always 1/6 on the roll of the dice. So the probability, 1 of the 6 possible outcomes, 17% chance. That's in theory. By experimenting, you can get different numbers, and we'll experience that in classroom once different people roll the dice and see how many out of the total rolls you will be getting, and we'll compare those numbers and we'll see the experimental probability. It depends on the experiment that you do and how many times you do the experiment. So how many times the 6, let's say, would come out of the 15 times that you would roll. And 2 out of 15, 2 divided by 15. In this situation, I have 13%. So it's still low chance, but it's based on my hypothetical experiment. So let's say I have the theoretical probability of getting an odd number. Odd number, so are 1, 3, 5, that's 3 out of 6 total possibilities. So 3 out of 6 is 3/6 simplified to a half, or 3 divided by 6 is still 0.5, which is 50%. Now, experimental probability, it depends on the experiment that we are going to do. So let's say I want to roll the dice, and I'm going to say in the classroom, everybody roll the dice 20 times and see how many 1s, 3s, and 5s you would get, or how many evens you would get, or how many times you will get a certain number. So the number of times can be what you want to be or given by the directions. So let me say, everybody in class roll the dice 20 times. And then see how many times do you get a 1, a 3, or a 5. So 1, 3, and 5, that's half of the possibilities, so it's 50% chance. So it could be quite a bit, right? So let's say I got those 13 times. 13 rolls. Out of those 13 times, it could have been a 1 or a 3 or a 5, an odd number. So I got 13 odds out of 20 times total that I rolled the die. So that could be 13 divided by 20, about 65%. That number will change. It will stay relatively close to 50. It could be on the lower or higher side, but it will be relatively close, not too far off, let's say within maybe 25% or so. So by experimenting, we're going to see more and more possibilities and see how many percent we can go off to one side or another. So let's see a few examples that we're going to see theoretical probability, and then in class we'll do the experiment and we'll see the actual experimental probability and see how close or far they can be to the theoretical probability. So for each event, we are going to calculate the theoretical probability you expect before the trial, and then the experimental probability, what you'll actually get after performing those trials. So for the coins, we have two possible outcomes, either heads or tails. So the probability in theory, in other words, TP, its theoretical probability to get tails is 1 out of 2, which is 50%. Then you're going to have a coin and you will flip it 20 times, and then you will count how many of those times will be tails. And that will be out of 20 because we will have that experiment done 20 times. So your number is going to be something that you will get how many tails out of 20 times. And then you'll convert that to percent. So for the die, the 1 and 2 is two possibilities out of 6 possible outcomes. So to get the 1 or 2, that's 2 possibilities out of 6 total, which reduces to 1/3, approximately 33%. Now you're going to roll the die 20 times and find the experimental probability of rolling 1 or 2. So the experimental probability will be how many times you get 1 or 2, and out of 20 times that you're going to roll. So your number will be here, how many times you get the 1 or the 2. And then we'll change that to percent. So the experiment will be done individually and the number of percent will be different, and then we'll compare. So for the event, rolling 12-sided die and getting a 9, 10, 11, or 12. 9, 10, 11, or 12, that's 4 possibilities out of 12 total outcomes because it's a 12-sided die. So for 12s is, we can put in a calculator right away, 4 divided by 12. That's approximately 33% chance, or we can simplify to 1/3 by dividing by 4. So we have that 33% chance to get a 9, a 10, an 11, or a 12. Then what you're going to do is roll the die 20 times and make an experiment. And your experiment is called experimental chance or experimental probability, converted to percent, that will consist of 20 times rolling the dice and then recording your number of how many times you see a 9, a 10, 11, or a 12 out of 20 times total. So you're going to record, you can use tallies to count how many times you will see a 9, how many times you'll see a 10, how many times you'll see an 11. You can put it here like next to the number 11 as you do the experiment. Then we'll divide and convert to percent to see how much is the experimental probability to get those numbers by performing that experiment 20 times. In the deck of cards, we have 52 cards, so 52 possible outcomes. So in theory, to draw a heart, we have 13 hearts out of a 52 card deck, which is a quarter of a deck, which is 25% chance. So 13 divided by 52 is 1/4 or 25%, because there are 13 hearts in the deck. So what you're going to do is draw a card and reshuffle. Draw a card, put it back, reshuffle. Draw a card, put it back, reshuffle. Draw a card, put it back, reshuffle. And you're going to do that 20 times. On the numerator, you are going to record the number of how many hearts you happen to draw. And then we'll see. And then once you draw a heart, you can put a tally mark here. Draw a heart and then keep track of how many hearts you're going to draw out of the deck after the experiment is performed 20 times. So draw a card, put it back, reshuffle. Draw a card, put it back, reshuffle, and see how many hearts you're going to draw in those 20 times. In the event, flipping a penny and getting a tail. So the number of outcomes is 2. So in theory, it is 50-50 or half chance to get a tail. It's 1 out of the 2 possible outcomes, 50% chance. Let's see then, by experimenting, how many tails would you get after you flip the coin 20 times. So the experimental probability is out of 20 because it's out of the number of times the experiment is performed. And the question or your experiment is to see how many times will you get a tail. So as you do the experiment, just keep tallies. How many times you have a tail. In rolling a die and getting a number greater than 2, we can have 3, 4, 5, 6. So we have 4 possibilities of getting a number greater than 2. So that's pretty large percentage. So out of 6 possible outcomes, 4 are greater than 2, or 4 faces, 4 numbers are greater than 2, which can be simplified to 2/3, and 2/3 is approximately 67%. Pretty high chance. Now, experimental probability, EEP, is out of the number of times you try, in other words, out of 20, you're going to see how many times you see a number greater than 2, either a 3 or a 4 or a 5 or a 6. So you're going to roll 20 times and then keep tallies. You see a 3, put a tally mark. You see a 4 or a 5, put a tally mark, and then record how many times you will get a number greater than 2 out of the 20 times of the experiment that needs to be performed. Rolling a 12-sided die and getting a 7, 8, 2, 3, or 11. So 7, 8, 2, 3, or 11. 1, 2, 3, 4, 5 out of 12 possible outcomes. So the theoretical probability is the number of how many outcomes we're looking for out of the total number of possible outcomes. So you're going to be interested in getting numbers 2, 3, 7, 8, and 11 out of 20 times of rolling a 12-sided die. So out of 20 times of the experiment, how many times do you see either a 2 or a 3 or an 8 or a 7 or an 11? So again, put tally marks as you roll, and then count, and then convert to percent. Oh, we missed here the 5/12. What was the 5/12 as a percent? 5 divided by 12, approximately 42%, almost half. Drawing a king or a queen from a deck of cards. So it doesn't say what kind of king or queen. So just either a king or a queen from a deck of cards. So the deck of cards, presumably 52 cards, we have 4 kings of each kind, 1, and 4 queens. So altogether, that's 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8 out of 52 cards possible. So to draw a king or a queen, it's pretty low chance, but let's see how many percent is that exactly. About 15%. Experimental probability is by doing. So you draw a card, put it back, reshuffle, see what you get. When you draw again, then put it back, reshuffle, see what you get again, and then you will see how many times out of 20 you will draw either a king or a queen. Okay, so keep tally marks as you perform that experiment. So you're going to do it 20 times. Draw a card, see if it's a king or a queen, record it, then put it back, reshuffle, do it again, see what you get, put it back, reshuffle, and see how many times you get either a king or a queen out of the 20 possible times you perform that experiment. Then we'll compare our percentages in class and see how far off is the experimental probability from the theory or theoretical probability.